Intro, excited tone. Hey there! Have you ever just stopped for a moment, tilted your head back during a bright sunny day and marveled at the sky? I mean, it's stunning. That endless expanse of blue above us, stretching as far as the eye can see. What's going on here? Why is the sky blue? Well, prepare to be amazed, because the real answer is more fascinating than you might think. And trust me, it's not just because of water or magic. Pause for effect. Take a seat, grab a glass of your favorite beverage, and let me take you on a colorful journey of molecules, photons, and a smidge of physics. Scene change. Hyper-realistic 4K animation of the Earth with a bright sky and molecular diagrams. First, you need to imagine a world without an atmosphere, just an empty void around the Earth. Picture that for a moment. In this imaginary world, the sun's light would hit the Earth directly, giving it a sharp, white glare. We wouldn't see a blue sky at all. In fact, the entire daytime sky would appear black, like space. So, what makes the difference? The answer lies in something we take for granted every single day: Earth's atmosphere. It's a combination of invisible gases, primarily nitrogen, 78%, and oxygen, about 21%, along with tiny amounts of argon, carbon dioxide, and other gases. This layer surrounds our planet and plays a very big role in creating that beautiful blue hue. Segment transition, 4K animation of sunlight interacting with the atmosphere, showing beams splitting. Now, let's talk about light. Sunlight looks white to the naked eye, doesn't it? But white light isn't just one thing. It's actually made up of all the colors of the rainbow. Think of a prism or a sprinkler throwing sunlit water droplets into the air that create a rainbow. These colors, red, orange, yellow, green, blue, indigo, and violet, all have different wavelengths. For instance, red has a much longer wave compared to blue, which has a short and snappy wave. Animation shows wavelengths side by side, red with long curves, blue with tight curves. Here's where it gets interesting. When sunlight enters Earth's atmosphere, it doesn't just sail through. Instead, it encounters billions, yes, billions, of tiny gas molecules. These molecules act like little obstacles for light. This is why light gets scattered, a phenomenon scientists call Rayleigh scattering. Pay close attention here. Rayleigh scattering happens more efficiently for shorter wavelengths. And since blue and violet light have the shortest wavelengths in the visible spectrum, they scatter in all directions when the sun's rays hit the atmosphere. But wait, you might be wondering, if both blue and violet scatter so much, why isn't the sky violet instead of blue? Excellent question. Gold star. Animation showing both blue and violet scattering, then fading out. Violet. The reason boils down to two things. First, our eyes aren't as sensitive to violet light as they are to blue. Second, a lot of that violet light gets absorbed by ozone in the upper atmosphere. So, what we end up seeing the most is, you guessed it, blue. Pause. Hyper-realistic 4K image of a bright blue sky with white clouds. Let's recap for a second. We've got sunlight, a mix of all colors, short wavelength blue light scattering across billions of gas molecules in our atmosphere, and our eyes are more tuned to blue than violet. Voila! A stunning blue sky. Isn't that beautiful? Transition to fun facts. Birds chirping. Serene, hyper-realistic nature visuals. Want to hear some fun facts? Sit tight for these. Did you know that sunsets are a perfect exception to this rule? Scene showing breathtaking red and orange. Sunset. During sunset or sunrise, the sun is much lower in the sky. This means sunlight has to pass through more of Earth's atmosphere to reach us. By the time it gets to us, most of the shorter wavelengths, blue and violet, have been scattered out entirely. What's left? Warmer colors like red, orange, and yellow. No wonder sunsets are so magical. Second fun fact, shifting to images of Mars. Here's another mind-blowing tidbit. On Mars, the sky isn't blue at all. It's actually a butterscotch color. That's because the Martian atmosphere is much thinner and made mostly of carbon dioxide, causing sunlight to scatter differently. Imagine standing on another planet and seeing a sunset glow in shades of blue and gray. Insert stunning artistic rendering of a Martian sunset. Science fiction? Nope. Just how light works. Scene transition. Returning focus to Earth with bird's eye 4K animation. Here's what's really astonishing. This incredible phenomenon of Rayleigh scattering doesn't just apply to planet Earth. Our understanding of light and atmosphere has helped scientists study other planets' atmospheres, discover exoplanets, and even design better telescopes to view faraway galaxies. Think about that the next time you casually look up at the sky. It's truly a window to greater knowledge. Concluding, soft, inspiring tone with image of Earth and starry space in the background. So, the next time someone asks you, "Why is the sky blue?" you'll not only have the answer, you'll also know it's a story of science, molecules, and cosmic wonder. Above all, it's a constant reminder that the world we live in is far more complex and beautiful than it seems at first glance. Share this mind-blowing fact with your friends, blow their minds, and let them marvel at the sky the next time they look up. All right, folks, until next time, keep looking up. The universe is full of wonders. See you in the next episode of Why Facts. Outro music fades out.